Okay, guys, today we're going to finish up talking about the moon. And we just have a few pages left on the slides. If you pull up your notes, you guys did this side last week. We went all the way up through phases of the moon. So now you just have these last three sections, how the moon affects the tides and the sizing and rising of the moon. So you should have this handy already. If you don't, pause the video and go grab that. It was what you did last week, so you should have it. Okay, so we're going to go ahead and pick up where we left off. Okay, so this is actually a really interesting photo. One of the videos that you guys will watch today shows this in a time elapsed video over the course of 12 hours. This is a certain place, and I can't remember the name of the city in Canada, that has the most drastic tide changes every single day. So every 6 hours, the tide goes all the way up like this. And then 6 hours later, it goes all the way down. And then 6 hours later, it's back up again. So in a matter of 12 hours, it goes, if it starts down, it goes up and down. So it's really actually kind of cool. You'll see this in the video later. But we want to talk about like how the moon is actually what affects the tide. So if you've ever been to the beach and, they'll, maybe it's high tide and or actually maybe it's low tide and you're building a sandcastle and then all of a sudden as the day wears on and all of a sudden the water seems to be approaching your sandcastle and your mom's like, oh, the tide's coming in. And before you know it, your poor sandcastle gets demolished by the water because the tide has come up really high. And then you could come back the next morning and the tide will be way down low again. And the place where you built your sandcastle, of course, it's gone, but you can build another sandcastle there. So it seems like the water is moving. The water goes down every day and then goes back up every day, but it's actually not what happens. So there's actually the force of gravity that makes us experience the tides. But the water isn't moving, we're actually moving. Remember, we're on the earth and the earth is rotating, right? So you've got two gravitational bodies that play a role, the sun and the moon. Obviously, we're a lot closer to the moon than we are to the sun. So we're going to get a lot more of the gravitational pull from the moon than the sun because we're pretty far from the sun, obviously. We're an astronomical unit away. So we're going to get a lot more from the moon. So this is what you're jotting down in your notes. The moon is much closer to the earth, so it has a much greater influence upon the tides. Okay, so we're going to find out, well, how does that work? So these pictures can be a little tricky to understand. So you've got, here's your sun, here's the earth, here's the moon. As we learned about last week when we were talking about the phases of the moon, and you guys have been kind of observing that each night and recording it on your calendar. This when the moon is between the sun and the earth, and so the part that's reflecting light is completely facing away from us, the far side of the moon. Remember, not the dark side, because it's actually lit up. We don't see the moon, so we call that the new moon. And then 2 weeks later, because remember, this is a quarter. So I'm sorry, not 2 weeks later. 2 weeks later, I'm sorry. 2 weeks later, we'll have a full moon where the whole part of the moon that's reflecting sunlight is visual to us. And so we see a full moon. When it's at new moon and full moon, it is getting the most gravitational pull from the moon. And the water on the earth, and I know this is a really exaggerated illustration, the water is not bulging out that far around the earth. But the water is technically being pulled by the gravitational pull of the moon, and it's just slightly bulged out from the earth. Okay, so hang with me here. So you got the earth, the sun, and the moon. They're fully lined up. You've got this gravity. We call this a spring tide when it's new moon and full moon, and you've got these big old tides. Okay, then when we're at first quarter moon and third quarter moon, and the moon is at like a right angle to the earth. We don't get as much of a strong pull, but you do have the water bulging that way as well. And these are called neap tides. Okay, so just hang with me now. We are going to look at some illustrations that show like if there was a person standing right here on the earth and the earth is rotating. Imagine if there's a little person here and the earth is rotating. Right now, if I'm hanging out on the beach and I'm on this part of the earth, the tide's going to be pretty high. But then as the earth rotates, my tide appears to go down, but I'm just really rotating out of high tide into low tide. Then I will rotate back to a high tide. Then I will rotate back to a low tide. So we're actually rotating among these tides, but the water isn't going up and down on the beach. That's what it seems like. Okay, so you should have jotted down when the moon and the sun are right angles to each other, the effects partially cancel out. That's called a neap tide. So it's not quite as high. So there's always a tide on either end of the earth. There's always tides opposite each other. They're not quite ready yet. They needed like 10 more minutes. Okay, so let's see here. I'm going to end this video because I want you guys to watch. Well, actually, this one, yeah, let me actually show. There's one video I can show you, and then the other one I'm going to end, and I want you to watch it and then come back. So let me escape out of this really quick, and I want to go to this one. Okay, if I can get it to zoom. This is only 20 seconds, and it doesn't really have any narration to it. But this is the moon. It's at least motion. So you've got, here's the sun, here's the moon, here's the earth, and here's, again, a very exaggerated illustration of the water being pulled by gravity. Okay, the water, the oceans that cover the earth are just slightly pulled. Think about how big the earth is and how small we are. It doesn't have to be a big pull for us to experience a difference. They just exaggerate it. So if I start this video, hopefully it'll work. So notice how the really high tides are following the moon. So it gets a little bit lower. See how this would be spring tide. This would be a neap tide. It's not as exaggerated. This would be a spring tide. Let me go back again. Oh, no, I don't want to do that. Again, so here's a spring tide and there's a neap tide. It's not as exaggerated. Spring tide, neap tide. Neap tide's still a high tide. It's just not as high as a spring tide. So every week you've got changes of really, really high tides, spring tides to neap tides to high tides to neap tides. So it's kind of interesting. Okay, let me get out of this. Go back to this. Okay, so that was what the little video was. So I'm going to close out of this really quick, and I want you guys to watch. Okay, I want you to watch. No. The Ocean Tides Explained. Okay. This is a good video. It's about 5 minutes, but it explains it really, really well. I don't want to play it here because I had a little problem with my high school class when I played a YouTube video while I was making a video. Then I posted it, then YouTube flagged it for copyright infringement, and I had to go back and edit the whole video. So I'm going to pause the video, and you'll see a link to Ocean Tides Explained. Okay, I want you to watch that, and then you'll come back for part 2 of our lesson. Okay, so I'll see you back in a bit.